In this video, we're going to continue looking at empirical formulas. And for this specific question, we're actually going to calculate the empirical formula using a hydrate as an example. So a hydrate is a compound that within its crystalline structure, so sodium carbonate here, has some water molecules trapped inside of it. So we're trying to figure out what the x is here. We're going to solve for x to determine the number of moles of water in the hydrate. So this is a calculation that is similar in essence to empirical formula calculations because we're going to find out the molar ratio of the salt, the sodium carbonate to the water. So let's see, starting with some of the information that's given here. We're told that we have 2.588 grams of this sample of this hydrate, and we heated it, and after heating, it was down to 0.948 grams. So we know that the mass of water then can be found by the mass of the sample minus the mass of the heated sodium carbonate afterward. So what's remaining? So if we start with 2.558 grams and then we subtract the 0.948 grams that was left over after heating, we would find that we have about 1.610 grams of water. So now we need both the molar mass of sodium carbonate, which we can find by adding about 23, so 22.99 for sodium, 12.01 for carbon, and then another 48 for 3 times 16 for oxygens in the carbonate, and that gives us about 105.988 grams per mole. And for water, we have two hydrogens, so 2.02 plus 16 gives us 18.02 for the molar mass for water. So now we can find out how many moles we have of our sodium carbonate by dividing this value here by this value here. So we take 0.948 grams of the sodium carbonate after heating, divide by the molar mass, and that gives us 0.008944 moles of sodium carbonate. So NaCO3. And the ratio is to water here, 1.61 divided by 18.02 gives me 0.08934 moles of H2O. So we can see there's about a tenfold difference in the amount of moles of water to sodium carbonate. So if we were to write the formula, oh, we forgot the 2 there, for our hydrate, it would be Na2CO3, and then we write this dot here to represent. There's 10 water molecules in this hydrate per each sodium carbonate. So times 10 H2O. So here's the empirical formula for our hydrate. And let's take a look at another example here that utilizes empirical formulas. And in this sample exercise 14, we have this compound here, which is a hydrocarbon that's found in crude oil. And we're told that it has an empirical formula. So its lowest whole number ratio of carbon to hydrogen is C3H4. And we experimentally determined the molecular weight. So what the compound actually appears like, the full amount of carbons and hydrogens, we should assume. It has a molar mass or molecular weight of 121 atomic mass units. So we want to know what is its molecular formula. So we can create what we can refer to as an empirical molar mass here, where we take the mass of 3 carbons, so 3 times 12.01, and then we add to that the mass of 4 hydrogens. So 4 times 1.01, so 4.04, and 36.03. So we have this empirical mass, as we can call it, that is about 40, right? 0.07 atomic mass units. And if we find a ratio of the molecular weight to this 40 atomic mass units, we find that it's about a 3 to 1 difference. So if we multiply C3H4, the empirical formula, by 3, we would find the molecular formula. So that compound that's mentioned up above would have the chemical formula of C9H12.